Project I want to show you is 410, which is here. This is exploiting an Android phone with Metasploit. And so the first thing to understand is the setup. What I'm using is I have a Debian virtual machine running in VMware, and I run it with bridge networking. This is really important. If I run it in NAT networking, my Android phone will not be able to network with the Debian device, and I need that to happen. So go to your network adjustments and go from NAT to bridged mode so it gets an address on your local area network. So I booted up the Debian machine and logged in. Now I'm going to give it IPA in the console just to see the address, which you see there starting with 172.17. And then I never want to use the console for normal working on a headless Linux machine, or really any Linux machine. It's much better to use SSH, because then you can control the interface much better and you can copy and paste. So I'm going to SSH in with SSH Debian at that IT address, which is 172.17. This is City College address, 18136. All right, and it gets in. I'm going to say yes, arguing about the, it's telling me the same machine has had many different addresses because I keep moving it around to different networks. All right, so I'm in. So now I can control it this way and not control it here in the console, which is really only there to show you that the machine is running. SSH is the way to control a cloud machine, or for in my opinion, any Linux virtual machine. It's easier this way. So there's my Linux machine. All right. Now I want my Android device. I've taken just Android Studio and run a device, and it can be, I think, any device at all. It doesn't matter. I chose one with Google Play just to show that I can do it with an unrooted phone. This one has API 30, but an Android 12, but I don't think it matters what version you have or whether it's rooted or not for what we're doing here. You just need a phone. So there's my phone. Now, I could connect to my phone by ADB directly from Linux, I suppose. But I'm used to doing it from the Mac itself, and I think I'm going to continue to do it that way. Doing it from the host is easier. Then it wouldn't matter what kind of networking you have. So right here, this is the Linux machine, and here's the Mac host, so I can do ADB devices -L, and I'll see it there. There's an emulator on there. So if you go to the project, now I've got my setup. All right, so you have to install stuff on your Linux machine, and in fact, there. I added the default JDK, there's missing. So you update and install all this stuff, and then you install Metasploit. Just curl it down and install it. I've already done this. If you have a slow network, it'll take a while. But anyway, now you've got Metasploit, and you have all the supporting tools to make Android devices, make Android apps. So now we're going to create a malicious app. And you can see the Android exploits here by just listing the payloads in Metasploit. And then there's hundreds of payloads, so I'm going to show only the Android results. And there they are. Now it's not a huge list. So you see I've got Android Meterpreter, reverse HTTP, HTTPS, and so on. All I have is Android Shell and Android Meterpreter. So those are the only exploits. And so all that means is a shell lets you execute command line commands, and Meterpreter is a different shell, lets you run some special commands they've added. And that's usually more fun. So in order to do this, you have to make a typical piece of malware that is going to phone home to the control server. So I need to, my command and control server is going to be the Debian machine, so I need to have its address. So I do IPA. Here's my Debian machine's address. Now I'm going to create the malware. With this command, this is going to use MSF Venom, which creates malware. It's going to do Android Meterpreter reverse TCP. There's a reverse shell, which is what you almost always use, which means it gets executed on the target device, and then that device is going to make an outgoing connection back to the server. The reason you do this is because many devices are behind network address translation, and they often have stateful firewalls like Windows, so you can't send incoming traffic. You can only send outgoing traffic, and this is more likely to work. So then you have to tell it where to phone to, which is the local host, and I'm going to write it in a raw format and output it as an APK file. It's going to make an Android file out of it. So this is all I need, except I need to adjust the IP address. This is the #1 mistake students make, is they put in the wrong IP address, like my demonstration address. You have to put in the right IP address of your Linux server, or the malware is going to phone home to some address it can't reach. In fact, one thing that's a pretty good thing to do to test, I thought of putting this in the project, but I didn't, but it is a good diagnostic procedure. You want to make sure your Android phone can reach this server. So it's not a bad idea to go in here and do ADB shell, and then ping that server. This is my Android phone, and it's able to ping the Linux machine. That's what you need. You need that kind of connectivity. The most common problem students have with all the projects is they can't get the networking set up. So I know the networking now is set up so my phone can talk to the Linux machine. So this will create the malware with 172.17. Looks pretty good. It's going to call it happyfunball.apk. And so if I look, there it is, happyfunball.apk. Now, I did it before. I did it wrong, and I had to make another one called happyfunball2. I'll just get rid of that. That was from earlier. I'm not using it. Okay, so there, happyfunball.apk is my malware. Now, I could bring it on the Mac and just drag and drop it on the phone, but see, what I'd like to do is set up a realistic situation where you're taking over a phone remotely. So you get somebody to install this somehow. Now, you could do it. You trick them into installing it. And I'm going to do it with ADB. Yeah, there's various ways to do it, but it's not going to run, though, unless it's signed. So the first thing I have to do is make a key with key tool. And, all right, I think I've already got it there. This one I made earlier today. I'm going to delete it. Okay, and this is the command that's going to make it, myreleasekey.keystore. This creates a self-signed key. I give it a password of just password. And now it's going to sign it with a fake certificate so I can give it the name and organization and all that. You just have to make sure and say yes at the last line here. All right, so it creates an RSA key pair, 2048-bit RSA key pair, good for 10,000 days, to sign my app with. Now I sign it with Jar Signer. This is why you had to install the Java Development Kit in order to get this Jar Signer tool. So this will sign it, and it's going to ask for the password, which is just password. And there, now it's signed. So it's signed, added all these things, made the APK file, and signed it all. So now I can install the malware. So you just do ADB shell. The first thing you do is turn off verify installs. I think this is turning off Play Protect, the tool that will make sure that all your apps come from the store. So I think that's what this is doing. I think that's what that verifier is. So I turn that off. Oh no! I did it on Linux, which is not. See, on Linux cannot connect, but my Mac can with ADB. So there, that's what did it. Okay. And now I'm going to install the malware, but I do have to get it onto the Mac. It's on my Linux machine, so I will get it with SCP. Should be in the project. Yeah, transfer it to your host system. You can do it with SCP, and I have an example here of the SCP command. I'm going to do it here. Let's get this out of the way. There it is. It's in the image up there. So I can SCP, the Linux machine, secure copy, Debian, at that same address I've seen before. In fact, I can get it here, IPA. It's this address, 172 and all that jazz. Okay. And then I put a colon. Now I have to give it the path to the malware. So I do print working directory. It's home Debian. Okay. And the name of it is happyfunball.apk right here. So I can copy and paste that. I think I might be kind of out of the projected area. Let me move there. Copy that. Okay. There. And I'm going to put it in the current directory. Put a dot there. Just put it where I am. So there it comes. Now I give it a password. Okay. And so now if I do ls-l, I've got Happy Funball, and this is from April 24 right now, so this is it. That's my malware. Now I'm going to install it on the phone with ADB install. ADB install Happy Funball. That's all you have to do. That'll push it onto the phone, and it'll tell me if it works. And it succeeded. Now, it might have failed for a lot of reasons. It might have failed if it wasn't signed. It would have failed if Play Protect was turned on. And it would have failed if it was for like ARM32, but my phone is ARM64 or something like that. But none of those bad things happened. It's got on there. So now I can launch the malware. Now, the user could be tricked into launching it, but you can also launch it remotely with ADB, and that's what we're going to do. But when you launch the malware, it's going to phone home to the command and control server, which better be ready. So the first thing you have to do is get your command and control server ready to receive the connection. So that is MSF console -Q just to make it quiet, otherwise it prints a big banner that irritates me. And after that's going, I just use the multi-handler. I tell it what payload I'm using. I tell it to listen on every available address, 0000, because I just don't care, and then exploit. That'll start a listener waiting for a connection on all the network connections on my Linux machine. And it takes about 10 seconds to launch. Now it's ready. So it's listening on port 4444 for any victims to phone home. So now that it's listening, now I want to launch the malware. And you do that, there's a command called monkey that will tap the screen for you. So this will tell it, tap on this thing, and the name of this thing is com.metasploit.stage. That's the name it gives the malware. So it's going to just activate the launcher method, just going to launch it the way you could by tapping on it. Let me get this out of the way so we can see the effect up here in Android. Okay, so when I launch it, there we go. Now, if you look at the phone, it's now asking for permission. So you have to say continue. Then it's going to say this app was built for an older version, but I click OK. And see, it has phoned home. It's connected, and then it sent the second part of the stage. It's a two-stage malware. Sent the second stage to it, and now I'm in. Now I can do help. I can do various things on the phone. Like I can do app list to list the apps on the phone to see if that works. Looks like that worked fine. I can install things. I can send an SMS. I can dump the SMS. I can check to see if the device is rooted. I can launch activities. You know, you can do a lot of things. You record the mic, turn on the webcam on the phone. I don't know if my phone has a virtual webcam or not. Screenshot didn't work when I tried it. It said you can only see a screenshot of the current app or something. But anyway, you can do various things. And so there's a flag of some sort to get here. But that's the point. That's success. That's when you have remote control of phones. This is the old-fashioned malware, Metasploit attacks. And this is what most people use. Most pen testers use this, or they use, I think, there's a famous commercial one that's expensive, Cobalt Strike. Cobalt Strike is the professional pen testing tool that does essentially the same thing, except it's real expensive and you can't get an easy free version, so the stuff is usually not detected by antivirus products, whereas Metasploit is detected by antivirus. I was thinking another project to do after this would be to install antivirus on the phone and watch it detect this and stop it, because everybody knows Metasploit payloads. I haven't written that one yet, but it would be a good thing to do. Anyway, that's what I wanted to show you. Let me stop the recording.